Hey everybody, good morning. This is Mr. Ainsworth, and we're going to get into our first semester final review. So get your review out. If you have your notebook out with all your notes, that'd be great. So you can access them, get your note cards out, get your red pen and pencils out, maybe a calculator if you need it. All right, and let's get started here. Okay, so very important here. Let's read the directions here. We got to find some unknown angles here. Very important here that we understand that the lines are parallel. Okay, look at the red arrows right here, and also look at the given here. The lines are parallel. When that happens, all kinds of things happen. Okay, first of all, the first thing I notice, and before I even start this problem, there's probably more than one way to do this. Okay, so keep that in mind. So if your method is slightly different than mine in terms of the order of how you solve for your variables, that's probably going to be okay. This is just what I think when I look at this problem and how I approach it. Okay, so the first thing I notice when I saw this problem is that these parallel lines are cut by two transversals, T1 and T2. All right, when that happens, the alternate interior angles are congruent. All right, I'm talking about this one and this one. Okay, so already I know that x is 30 degrees. Okay, so I'm going to put 30 degrees here. Alternate interior angles are congruent when the lines are parallel. Let me write that down. So alternate, actually, let me state this. Since the lines are parallel, that tells me that the alternate interior angles are congruent. I'm just going to write down the theorem I'm using right here. So x is 30 degrees. And I'll color code them too. I'll tell you what, right there and right there. I also notice that vertical angles are congruent. So if that's 30 degrees, well, that's 30 degrees. So I know that vertical angles are congruent. So I'm using two different theorems here to solve the problem. So first use alternate interior angles are congruent. X is 30 degrees. Then I go vertical. Z is also 30 degrees. And then I notice that these three angles here must add up to 180. They're supplementary. I'm going to use the angle addition postulate. So what I know is that 30 plus y plus 62 is 180. So 30 plus y plus 62 equals 180. Let me see, that's y plus 62 and then 30 is 92 equals 180. So y has to be 88. Okay, so that's 88 degrees right there. That's another thing I noticed. And then I notice I got a triangle right here. And there's different ways you can solve for W here. You can go corresponding here. These are called corresponding angles. So already I can see that this right here, this angle, is 62 degrees. You can use the corresponding angle postulate. Okay, when A is parallel to B, that implies that the corresponding angles are congruent. You could do that. Or you could use vertical angles again. You could say, hey, if this is 88 degrees here, so is this. This is 88 degrees. And then you can use the triangle sum theorem. And you can add up 88 and 30. Okay, this is 30 degrees. And get 118. And then subtract that from 180 to get 62 for W. So you can also use your triangle sum theorem. There's all different ways you can solve for your unknowns. Okay? You just got to get creative. Number two, I want you to pause the video and give it a shot. All right? Very, very similar here. You got to solve for the unknown angles here, and there's many ways to do it. All right, so hopefully you've solved the problem already and you're checking your work. So let's see here. Uh, so let's see here. I know that this angle right here and this one are congruent. They're both 45 degrees because the corresponding angles are congruent. I know that because the lines are parallel. So I'm going to use the corresponding angle postulate again. Corresponding angles are congruent. Because of that, I know x right here is 45. Oh, I can use alternate interior angles again. That's probably even easier. So this angle right here is 45 degrees because the alternate interior angles are congruent as well. Alternate interior angles are congruent as well. If that's 45 and that's 61, let's see. So 45 plus y plus 61 is 180. All right, and that tells me that 106 plus y equals 180. That tells me that y is 74. So this angle right here is 74 degrees. Okay, and then I'm inside the triangle. Now we know that the triangle sum theorem says that the three angles in a triangle always sum to 180. It's called the triangle sum theorem. Always sum, or okay, you can say add to 180. So 74 and 45, so 74, 45, that's 119 degrees. 180 minus 119, well, that's 61 degrees, okay? So Z right here is 61 degrees. And notice that Z and W are supplements. Supplements always add 180. And I'm talking about like right here. These two right here, they're supplementary, right? So 180, all right, minus 61 is 119. So W is 119 degrees. So this angle right here, 119. Or you can say W is 119 degrees right here. Okay? So you just have to use a variety of different theorems and postulates to your advantage to solve for the unknown. That's all you have to do. All right, number 3, you have to provide a counterexample. All right, a counterexample right here is an example, all right, to show something is false. Okay, so here's the false statement. If a number is divisible by 6, it's also divisible by 12. Well, 6 is a counterexample. There's many, okay? There are many counterexamples. All right, 6 is one of them. Why? Because 6 divides into 6, but 12 doesn't. All right, doesn't divide it at all. 18 would be another one. 6, 18. 6 divides into 18 3 times, but 12 doesn't. Evenly, that is, okay? So there's many counterexamples that can prove this is false. Like number 4 here. You try it now. If a number is divisible by 8, like 8 or 16 or 24, then it says here that it's also divisible by 16, but that's false too. Because 24, let's say, okay, 24 is your counterexample here, one of many. Okay, one of many. 8 divides into 24 3 times, but 16 doesn't. Okay, a whole number of times. Another one, 32 is not a counterexample because 16 divides into 32. 32, 40. 40 is a counterexample. 8 divides into 45 times, but not 16. Okay, so there's many counterexamples there. Okay, number 5, the midsegment theorem here. It states that if you have a midsegment, which is created by connecting two midpoints of a triangle right here, it states that it's not only parallel to one of the sides, but it's also half the length. Okay, so here's the midsegment theorem. So it's two parts. Part 1 is that BD is parallel to CE. That's the first part. Second part, BD, let's take away the segment symbol, is 1/2 the parallel side. I'm talking about CE. So 1/2 of CE. Or you can say that CE is 2 times the length of the midsegment. So which is where how most people would tend to use it because it avoids the fractions. So C is 2 times the length of the midsegment. So 2 times BD. This one's easier to use because there's no fractions involved, right? It's just double the length. So the longer one is twice the shorter one. It's that simple. Okay, we're talking about the two parallel sides here on the midsegment. So the longer side, the parallel side, is 2 times the midsegment. Let me write that out in words. The parallel side, and I'm talking about side CE here, all right, is equal to 2 times the length of the midsegment. There's your theorem in words. Okay, that means the same thing. All right, so now let's use it. All right, so on this one here, all right, the parallel side, this one, here's the parallel side. The parallel sides here. The longer one is 2 times the shorter one. So I would start off by saying, okay, 4x plus 8 is equal to 2 times the shorter one, the midsegment. So where this is your midsegment right here. Okay? That's how I would start it off. So then you go for it. You got to solve for x. So 4x plus 8 is equal to 100. Subtract 8. And you get 4x is equal to 92. Use your calculator if you like. All right? Divide by 4. Take 92 divided by 4. All right, and you get 23. All right, so x equals 23. There we go. That's all there is to it. All right, so you set the parallel side equal to 2 times the length of the shorter one, the midsegment, and you solve. Now you try it. Pause the video and give it a shot, and then press play when you're ready. All right, so hopefully you tried the problem. So here we go. So 5x plus 4 is equal to 2 times 60. 5x plus 4 is equal to 120. Subtract 4. 5x is equal to 116 divided by 5. So 116 divided by 5 divides twice. 5 into 16 is 3. Remainder 1, so 23 and 1/5. So 23 and a fifth. All right, there you go. There's your midsegment theorem. Now let's switch to parallelogram facts. Okay, so here we go. The very first thing, by definition, all right, we know that parallelogram is a quad with 2 pairs of parallel sides. All right, it's a quad with 2 pairs, okay, of parallel sides. So let's get out your red pen and let's highlight. We got first pair here, second pair here. Opposite sides are parallel. I'm going to put that in red. Opposite sides are parallel. That's the first thing we know by definition. All right, DEF stands for definition. Now we proved some things about them. All right, and one of the first things we proved is that opposite sides are congruent. So in a parallelogram here, opposite sides are congruent. Opposite sides are congruent. That's the first fact. So these 2 sides are congruent. These 2 sides are congruent. All right, both pairs of opposite sides are congruent. Another thing we proved that is in a parallelogram, opposite angles are congruent. Opposite angles are congruent. So let's state that. So first pair here is the acute pair, and then the obtuse pair are congruent. Opposite angles, these are called opposite, as well as the other pair as well. Okay, opposite angles are congruent. And then the last thing we proved together is that if you take your diagonals, diagonals bisect each other here. So if you have a parallelogram, the diagonals bisect each other. What do I mean? I mean that the long diagonal's been bisected into 2 equal parts, 1, 2, and then the shorter one's been bisected into 2 equal parts. Bisect means cut into 2 equal parts. Okay? And so with those facts, we can solve all kinds of problems. Okay, so let's go for it here. All right, the very first thing we know is that opposite angles are congruent. So the very first thing I can do is I can say, hey, opposite angles are congruent here. These are opposite. All right, and they are congruent here, so this one must be 74 degrees. That's the first thing. Opposite angles are congruent. Now, it says label all, okay, all the unknown angles. We're not done yet. I also know that same side interior angles are supplementary. Same side. Let's go in way back here. I got parallel lines cut by transversal here. Same side interior angles are supplementary. That means that, let me switch to blue now, that these two right here are supplementary. Why? Because you have parallel lines cut by transversal. Look at this. No. Parallel lines cut by a transversal. These 2 angles here are same side interior. They're supplementary, which means they sum to 180. Okay, so 180 minus 74 gives you 106. So this is 106 degrees. And if that's the case, then this is 106 degrees too. All right, so I found all 4 angles. Ooh, what's up with this diagram? This got all messed up. So let me clean this diagram up because something happened in my program here. Okay, so let's fix this here. Right here. Okay, so this is 108. So you go straight across to the opposite angle. That's 108. All right, and then these are supplementary here, these same side interiors. So 180 minus 108, well, that's 72. So you put those in. This is 72 degrees here because these are supplementary, see? and then you go straight across, and the other opposite angle is 72. So you have two obtuse angles that are congruent, and then the acute angles are congruent inside any parallelogram. So I use two different theorems there. Here I've got a parallelogram and the opposite side, these are opposite side lengths. All right, opposite sides are congruent. Opposite sides are congruent. So I know that 2x plus 10 is equal to 5x minus 20. Do a little algebra, okay, boom, like that. You get 10 is equal to 3x minus 20. At 20, and you get 30 equals 3x. 3 times 10 is 30, so x equals 10. Okay, so it's just an application of your theorems here. All right, now you try the next one. Pause the video and give the next one a shot because it's almost identical, right? Opposite sides are congruent. That's the key. Okay, so on this one here, opposite sides are congruent, so you set them equal to one another. That's what congruent means. So 7y minus 6 equals 3y plus 2. Do a little algebra again. So 7 minus 3 is 4, so 4y minus 6 is equal to 2. Add 6. 4y equals 8, so therefore y equals 2. 4 times 2 is 8. Okay, on this one here, we have a parallelogram signified by the arrow symbols, right? Opposite sides are parallel. So we have a parallelogram, and I know that the diagonals bisect one another. So I have to use that key concept. Diagonals bisect one another here. So I set 40 is equal to, these parts are, well, the diagonals have been bisected, which means the two parts are equal. So 40 equals 6x plus 4. Subtract 4, 36 equals 6x, and x equals 6. Believe it or not, it's that easy. So give the next one a shot. Set the parts on the diagonal equal to one another and solve for the unknown. Go ahead, pause the video, give it a shot. Make sure you try it first before you listen to me and check your work. All right, so let's check. So we got 6x plus 4 is equal to 60 minus 4. We have 6x equals 56 divided by 6. So 56 divided by 6 divides in 9 times, 54, remainder 2. So x is equal to 9 and 2 6, or 9 and 1/3. Okay? All right, now let's go on to vertical angles here. Okay, first of all, vertical angles are congruent. So let's state the key concept. All right, vertical angles are always congruent, So that tells me in this diagram that this angle here must be 138. All right, next thing I know is that these two are supplementary. All right, they add up to 180. So that tells me that x plus 138 is equal to 180. And if you subtract 138 from 180, you get x, and that has to be 42 degrees. Okay, so this angle here is 42 degrees, and so is this one, just for funsies, okay? So the two acute angles in vertical angles are congruent, and the obtuse angles are congruent. Anytime you have two intersecting lines, it forms two pairs of vertical angles. All right, so pause the video, get the next one a shot. Okay, let's check your work. So first of all, the acute angles here are congruent, so this is 46 degrees, so y equals 46. All right, and then these right here are supplementary. All right, so x plus 46 is equal to 180, so minus 46. And you get x is equal to 134 degrees. Okay, so this is 134, and this is equal to 134 degrees. There you go. That's all there is to it, guys. All right, linear pairs are supplementary. All right, that's what you have to remember. Okay, they're supplementary. Oops, supplementary here. That means they sum to 180 degrees. Key concept right here. So x plus y equals 180. They're supplements. So you've seen me do this a lot. So these two angles add to 180. There's your linear pair. All right, so these two add up to 180. They're supplements. So x plus 158 is equal to 180. If you minus 158 from 180, you get x equals 22 degrees. All right, use your calculator if you want, or just do the arithmetic, okay? Give the next one a shot. These two sum to 180. Give it a shot. Work ahead, all right, if you haven't done it yet. If you did, just keep the video rolling and check your work, all right? So y plus 43 equals 180. After you subtract 43, all right, you get y is equal to 137 degrees. All right, the obtuse angle is 137. All right, let's go over some basic definitions that you need to know. Definition of perpendicular is that two perpendicular lines always form right angles. All right, two perpendicular lines always form, all right, which is 90 degrees. All right angles. They look like this, guys. All right. So it doesn't matter how you orientate them, but you want to draw the right angle between them. It must be perpendicular. L1 is perpendicular to L2. L1 perpendicular to L2. There's a 90-degree angle right there. That's what it looks like. Definition of bisect means that to cut or divide into two equal parts. You have to know the basic definitions, especially in your proofs. All right. What does it mean to be parallel? It means to have the same slope. All right. Parallel. Come on. The lines have equal, keyword equal, slopes. All right. You have to understand that when you solve all kinds of coordinate proofs. All right. They have to, if they're going in the same direction, they have the same slopes. They have the same rise and run. Right? Rise and run. Same thing right on both of them here. Same slopes equal slopes. What does it mean to be perpendicular? Ooh, okay. Perpendicular lines don't have equal slopes. They have opposite reciprocal slopes. So perpendicular lines, all right, have opposite, here's the key word, okay, opposite reciprocal slopes. That's important, okay? One's positive, one's negative, and the reciprocals of each other. So that's really important. And what do you need to know? You also need to know all the definition of your quads. So there, I want you to refer to notes in 6.1. So refer to 6-1 notes. All right, memorize all definitions. Memorize, know all definitions. So that's up to you. Make some note cards. All right, that's what I used to do as a kid. Do whatever it takes, unless you already know them. Right? Okay. Okay, so now let's go through a proof here. All right. All right, now when you start a proof, you always start with the given, right? So let's start off with A parallel to B. Let's put down here, we want to prove that angle 5 is congruent to angle 7. So let's highlight that so we can get some focus here. So 5 is congruent to 7. We got to somehow get those congruent. And in these kind of proofs, you always want to start off with the corresponding angle postulate. And it states that if the lines are parallel, the corresponding angles are congruent. The question is, what corresponds with 5? I want to use the corresponding angle postulate. And it states that if A is parallel to B, all right, the corresponding angles are congruent. That's what it states, but you got to find it, right? So what corresponds with 5? Now, 5 is in the upper left. What other angle is in the upper left? Okay, and hopefully you picked angle 2, all right? These are called corresponding angles. So angle 2 is congruent to angle 5. Why? Because if the lines are parallel, which they are in step 1, it's given, the corresponding angles are congruent. All right. Number 3, I noticed that I have vertical angles here. Right here, They're vertical angles. And I know they're always congruent. So I'm going to say that, hey, angle 2 is congruent to angle 7. Okay? Why? Because vertical angles are always congruent. That's a vertical angle theorem. So why do steps 2 and 3 determine 4? Well, let me see. If 5 is congruent to 2 and 2 is congruent to 7, then 5 is congruent to 7. These are got to be congruent because of the transitive property, okay? 5 is congruent to 2. Look at this. Let me show you the flow. 5 is congruent to 2. 2 is congruent to 7, all right? So therefore, right here, angle 5 must be congruent to 7. They're all congruent to one another. Here, let me write it this way. Angle 5 is congruent to angle 2, and that's congruent to angle 7, all right? Let me write that a little bit better. Angle 7 here, and guess what? They're all congruent, all right? And that's why that's what the transitive property is all about. So the transitive property needs to be used when you relate 3 different things here. If all 3 things are equal or congruent, then any 2 are equal. Okay, so 5 is congruent to 7, and you're done. Now you try it. Now this one's similar. I just switched up all the numbers. Okay, so what you're going to do is you're going to start off with parallel lines. A is parallel to B. That's given. This time you're trying to prove that angle 6 right here, all right, is congruent to angle 8, the alternate exterior angles. You're proving the alternate exterior angle theorem, by the way. All right, so let's just put that at the end of the proof here. This is your goal. All right, and you want to prove that. So you got to start off with corresponding angle postulate just like in the previous one. So 1 implies 2. Go ahead and pause the video and give it a shot. All right, now 6 and 3 are corresponding angles, and they're congruent. So I'm going to state that. So angle 6 is congruent to angle 2. Because if when the lines are parallel, corresponding angles, okay, are congruent. And then right here, this time, I've got 3 and 8 vertical, so 3 is vertical with 8. So angle 3 is congruent. Ooh, I didn't write that down. This should not be angle 2 here. It should be angle 3. So angle 6 is congruent to angle 3 because the corresponding angle is congruent. Angle 3 is congruent to angle 8, all right, because vertical angles are always congruent. All right, and if that's the case, well, let me see. Angle 6 is congruent to 3, but angle 3 is congruent to 8. That means angle 6 is congruent to 8 by the transitive property, and we're done. Transitive property. There we go. All right, let's go back to the segment addition postulate now. And it states that if the 3 points are collinear, so if A, B, and C are collinear, that means they line up on a line, right? Are collinear, then AB plus BC, the sum of the 2 parts, right, is equal to the whole segment, which is called AC. So AB plus BC is equal to AC. The sum of the parts always equals the whole. Sum of the parts equals the whole. Okay, there's the key idea. Let's apply it, okay? So I'll show you the first one, you can do the next one. So 2x here plus 4x plus 6, there's the sum of the parts, equals the whole. Okay, this is the whole length. The entire thing. The whole enchilada, as they say. All right. Combine like terms, 6x plus 6 equals 60. Subtract 6, 6x equals 54. And then x equals 9. All right, now you try it on the second one here. The whole length is 48. The 2 parts are 3x plus 5 and 20. Pause the video, give it a shot. All right, so let's check your work. All right, so here we have 3x plus 5 plus 20. You add the parts, set it equal to the entire thing. All right, Okay, combine like terms. So 3x plus 25 is equal to 48. Subtract 25. So 3x is equal to 23. Divide by 3. So 23 divided by 3. 7 and 2/3. So x equals 7 and 2/3. All right. So on this one here, number 3, it's a little bit different here. We're not given a total length. We're given this right here. So notice the symbols right here. AB and BC have been marked equal. Okay, so I'm going to say I notice here that we have equal parts. That's the first thing I know. So we don't do the same thing we did as in parts B and C. If we have equal parts, we set them equal. Okay, and that's as simple as we get. So 8x plus 3 is equal to 63 actually. So what you do is you set the parts equal, then you solve. So 8x must be equal to 60. After you divide by 8, take 60 and divide by 8, and divide 7 times. You get 4. Remainder 4, so 7 and 4/8. So x equals 7 and 4/8, 7 and 1/2. Okay? All right, now we're going to switch to angles now and go to the angle addition postulate. Once again, the sum of the parts equals the whole. Sum of the parts equals the whole. And the whole entire angle right here, the biggest angle, is 124 degrees. So we have two angles, two parts that form 120 degrees. So if I'm just color coding here so you can see how it makes sense. You take the yellow angle and plus the blue angle, and you get the big angle, the big obtuse angle, 124 degrees. So you take x plus the other one, which is in blue, 3x plus 10, and you get it equal to 124 degrees. All right, so you add like terms, and we get to 4x plus 10 equals 124. Subtract 10, you get 4x is equal to 114. Divide by 4. I'm assuming that you've already done this, so that's why I'm going a little bit faster than normal. So 4 and 11 divides twice. All right, remainder 3. Bring down the 4. 4 into 34 is 8. 8 times 4 is 32. Remainder 2. So 28 and 2/4. So 28 and a half. So x equals 28 and a half. Sum of the parts equals the whole. Okay, you just add the two angles. First angle in yellow plus the second angle in blue equals the whole. Okay, that's all there is to it. Now you try it. All right, try number 19. Okay, now this one here, the two parts are of this right angle here are 20 degrees and 4x plus 16. So once again, angle addition postulate. You add them up and set it equal to your right angle. All right. So you got 20 degrees plus 4x plus 16 is equal to your 90-degree angle. All right, a right angle. Right angle there equals 90 degrees. So the sum of the two parts equals 90 here. So you add 20 and 6 is 26. So 4x plus 26 is equal to 90. Subtracts 26. And you get 4x is equal to, I don't know, 64. Divide by 4. And you get x is equal to okay, should be 4 here. 18, right? No, 16. Excuse me, 16. 4 into 24 is 6. Okay, come on. There we go. So x equals 16. All right, same thing. You have two angles here, and they form a 90-degree angle. Let's put the 90-degree angle back in there, because I forgot to mark that. So you've got this angle here. All right. And then you've got 15 degrees here, and they form a 90-degree angle. So you take 15 degrees, add it to 3x plus 10, and you set that equal to your right angle, and you solve it. All right, now if you haven't done that, pause the video and go for it. So you have 3x plus 25 is equal to 90. Subtract 25. You get 3x is equal to 65 degrees. Divide by 3. And let me see, 65 divided by 3, 21 and 2/3. Okay? All right, now let's try a few more here. Isosceles triangle theorem, okay? And that states, there's key concept again, that angles opposite, all right, of the congruent sides are congruent. So I go side to angle. Remember how I said that in class? Side to angle. So side to angle, side to angle. These two are congruent. All right, so I mark them both X. So because if one's X, the other one is 2, and they have to be the same. And then you kick in your triangle sum theorem. All three angles sum to 30. So all three angles sum, not to 30, but to 180. Sorry, that's the triangle sum theorem. So let's use that. So x plus 36 equals 180. That means 2x plus 36 equals 180. So 2x is equal to 144 here. All right, divide by 2, and you get x is equal to 72. Okay, so this is 72 degrees, and that's 72 degrees. You subtract the given angle from 180, and then take half of it in each position there. Now you try it, same thing. All right, these two angles here are the same, so then both y. So y plus 102 now, top 2's equals 180. Pause the video and give that a shot. Now let's check your work. We got 2y plus 102 equals 180. Subtract 102, and you get 2y is equal to 78. Divide that by 2. So 78 divided by 2 is 39. So y equals 39. All right. Now a couple definitions here. Complement, all right, sum to 90. Okay, complement, they sum to 90. Supplements, they sum to 180. Just some basics here that you have to know. Definition of slope, okay. For slope, so let's say that slope equals a couple things. First of all, rise divided by run. How do you calculate it? y2 minus y1 divided by x2 minus x1. So know your definitions. All right. And once you have that in mind, then you can calculate. So let's subtract up. So here we go. So 9 minus 6. 9 minus 6, you start off with y values, right? y2 minus y1 divided by 3 minus a negative 4. You get 3 divided by 7, or 3/7. It doesn't matter where the points are on the graph or just given to you in different ways. All you do is subtract the y's and then subtract the x's, starting off with the y coordinates, which are 4 and 2. So it's always x1, okay, you can call this one x1 comma y1, x2 comma y2. So 4 minus 2 divided by 4 minus 0, you get 2/4 or 1/2. That should make sense because, the graph's a little bit off. That's because I shifted things. Sorry about that. Okay, it shouldn't be off on your paper though. Let me fix this one before I go over it here. Because when I modified things on my key, things shift a little bit. That's the way it should be on your paper there. Okay, so on this one here, you take any 2 points, all right, and you start finding the slope. Okay, you got to go down 3, right 2, so it's negative 3/2. I can already see that. Or 4 minus 1. 4 minus 1 divided by negative 1 minus 1. So negative 1 minus 1. That's 3 divided by negative 2. Or you can use the rise and the run, however you want to do it. I like using visual aids right here. I look at the triangle here, and I see the rise and run, or I can do it right here too as well. I can see the slope on the grid, so I go down 3, right 2, so it's negative 3/2. Okay, or you can use the points. Okay, rise divided by the run, negative 3/2, same. Okay, Let's go over some algebraic stuff that we haven't done in a while, okay? Given 2 points, find the equation of the line. All right, I'm talking about y equals mx plus b. All right, through the points. The first thing you need to do is find the slope. M's the slope, so let's do that. So m is equal to 12 minus 4 divided by 6 minus 2. That's gives me 8 divided by 4, or 2. So the slope is 2. And then I want to find the equation. So y minus y1 is equal to m times x minus x1. I want to use point slope form. So I'm going to substitute my point in. I'm going to use this point right here, x1, y1. So I've take y minus the y coordinate is equal to the slope times x minus the x coordinate of 2. Distribute. So y minus 4 is equal to 2x minus 4. Add 4, and I get y is equal to 2x. Sometimes the y-intercepts cancel out, so don't worry about it. Now you give it a shot, okay? Find the slope first, work ahead. Okay, so 13 minus 1 divided by 2 minus a negative 4. So the slope here is 12 divided by 6, which is 2 again, holy cow. And then y minus y1 is equal to m times x minus x1. You pick a point, like the first one here, doesn't matter. Or you can pick this one here, it doesn't really matter which point you pick. So y minus, I'll pick the second one just for funsies here. Y minus 13 is equal to the slope times x minus the 2 again. So you have y minus 13 is equal to 2x minus 4, because you got to distribute twice, right? Add 13, and you get y is equal to 2x plus 9. 13 minus 4 is 9. So there you go. So know your algebra, okay? Now this one here, you got to find the equation line parallel. Now the key idea is this right here. Parallel means the same slope. So the question is, what's the slope of the line? So by looking at it right here, let me just change this, fix this graph just a teeny bit here. Like I said, some things changed when I made the key here. There we go, that's a little bit better. So between the slope between the points, I could see it's right here, up 1, right 2. So the slope is 1/2 by looking at the graph. Okay, and then the point right here, x1 comma y1 here, the point is 0 comma 2. That's my x1 comma y1. So I always start off with point slope form. So I write that down first, and then I get started. Okay, I take my slope and I substitute it in. I put the 2 here and the 0 here in the correct position. So y minus 2 is equal to 1/2 times x minus 0. That's y minus 2 is equal to, well, 1/2 times x, or just a half x. I add the 2, and again, y is equal to 1/2 x plus 2. Okay, that's parallel to the line here, and it passes through 0 comma 2, the y-intercept. All right. Now that's just a little bit of algebra. Now let's go back to geometry here. Given a pre-image here, we're going to rotate counterclockwise and clockwise. So at this point, what we want to do is remember our rules, okay? And then we could use our trace paper too. So we need the 90-degree rotation rule. So let me put this in red. So 90-degree clockwise rotation rule. And we also need a 90 degrees counterclockwise rotation rule. We need to get these. These are on note cards. So get your note cards out. X comma y gets rotated somewhere, and then x comma y gets rotated somewhere else on the counterclockwise rule. So let's see here if we can find this. I'm going to pause the video and see if I can find my original notes here. I want you to do the same. Okay, so if you had a moment to take out your notes on rotations here in section 9.3 out of your binder, you would scroll down here a little bit and you'd be able to see all your rotation facts. Or if you had note cards, because take out your note cards here, we took a look at these facts here about how to rotate around the circle here, either 90 degrees clockwise or 90 degrees counterclockwise, or even 180 degrees. Like right here, there's a 180-degree rotation right here, in which case that was where we took any point here and we went from 4, 3 to -4, -3, where we switch both the signs. So negative x comma negative y. So um, let's take these three rules right here and let's bring them over here and let's practice them, okay? So let's write them down. Starting off with a 90 degrees clockwise rotation here. Every point changes from x comma y to y comma negative x. So let's write that down on our review. So here we go. So our rule states for a 90 degrees clockwise rotation that every point, this represents a point here, changes to y comma negative x. So y comma negative x. Going back to our notes here, our counterclockwise rotation rule for 90 degrees is negative y comma x. So let's go back and let's write that. So negative y comma x. And if we had to do 180-degree rotation, either clockwise or counterclockwise, it doesn't matter because you get to the same point. All you do is just change the signs of the coordinates. So negative x comma negative y. So those were on note cards. NC for note cards here. You can take a look at them and get yours out from a long time ago and use them to your advantage. Okay, so here we go. So what we're going to do is we're going to rotate each vertex. So I'm going to write down the coordinates. This is -1, 4. So -1 comma 4. And this one's negative. My graphs have been switched here. Hang on for a second. Let me do this a little bit better here so it makes more sense. That looks better. Let me fix this one too. Give me a second here. Got to make it look real good here. There we go. That should be more like it. Okay, so what we do is we write down the coordinates of each point and then we apply the rotation rule and then we replot. Okay, so B is -3 up 1, so -3 up 1, and then C is just -1 comma 0, so -1 comma 0 here. So I'm going to start off with A. So A starts off at -1, 4. And then A prime, if you apply the, let me see, let's go clockwise first. You know, we're only going to do clockwise because I don't have enough room for counterclockwise. I didn't leave enough room here. So we'll just do this one here. So what you want to do on the 90 degrees clockwise rule is you want to start off with a y coordinate and then take the opposite of x. This right here, it means opposite. Okay, that's all you do. So you start off with the y coordinate, which is 4, and then the opposite of -1 is 1. So 4 comma 1. So A prime is right 4 up 1 right here. Okay, next one, B, is at -3, 1. So B prime, I got to take the y coordinate, which is 1, then take the opposite of x, 3. So B prime is at 1 comma 3 up here. The C is at -1 comma 0. So C prime, take the y coordinate 0 and take the opposite of x, 1, 0, 1, which is right here. Okay, there's my C prime, and then you connect. So you connect those images and you get the same triangle but rotated. So there's my image right there. Okay, it's been rotated. You can also use trace paper to verify. So let's write that down too. So use trace paper to verify. And if you don't remember how to do that, well, see me in class and I'll help you out, okay? And you can also rotate that counterclockwise too using the other rules. Okay, using the second one right here. It's a little bit different. It gets rotated down here. We might be able to do it. Maybe I'll be able to fit that in here. So let me see if I can do that. So A, which is -1, 4, goes to A double prime this time. And this time we got to take the opposite of y comma x. So the opposite of y is -4 comma x -1. So -4 -1. That's right down here. A double prime. B is at -3, 1, and it goes to B double prime. So let me see, you got to take the opposite of y comma x. So -1 comma -3. So left one down 3, it's down here. B double prime. And then C just one more time. -1 comma 0 goes to C double prime. Opposite of y, opposite of 0 is 0. And then comma x here, which is -1. So 0, -1 is right here. C double prime. And so if you connect these, it looks like right here. Here's my image. Okay, so this way is counterclockwise. This way is clockwise. So I was able to get both images on there. How about that? Okay, and that's all you want to do on these right here. All right, so let's do it one more time. So we got -2 comma 3, -2 comma 3. I always write down the coordinates. -4 1, so -4 1 here, and -1 comma 0. Write down the coordinates, and then you go for it. So on this one here, so A, which is at -2 comma 3, goes to A prime. Let's do a clockwise rotation first. Okay. If you look at the rules here, let me see if I can make this smaller here. There we go, so you can see the rules. So 90 degrees clockwise, so y comma opposite of x. So the y coordinate is 3. Just look at it right here. This is x and this is y. And the opposite of x, opposite of -2 is 2. So 3 comma 2. So write 3 up 2. There's A prime. And then B, which is at -4 1, goes to B prime. Opposite of, or excuse me, y comma opposite of x. So y coordinate is 1. Opposite of -4 is 4. So 1 comma 4. So way up here. There's B prime. C, -1 comma 0, goes to C prime. And it's y comma opposite of x, so 0 comma 1. 0 comma 1 is right here. C prime. And then you connect. And there's my image. There's a clockwise rotation. All right, counterclockwise. Let's do it one more time. That's, if you look up here at the rules, it's -y comma x. So we got to take the opposite of y comma x. So A, which is -2 comma 3, goes to A double prime. Opposite of y, -3 comma x. -3 comma -2. So left 3 down 2. There's A double prime. And then B, which is at -4 1, goes to B double prime. Opposite of y, -1 comma x. So -1 -4 down here, B double prime. C is at -0 comma 0, goes to C double prime. Opposite of y is 0, comma -x. So down here, C double prime. So when you connect there, your image gets rotated counterclockwise down here. Okay, so once again, this is a counterclockwise direction, clockwise in the hands of the clock going to the right. Okay, when you reflect over the x and y axes, what you have to remember here is a slightly different concept. All right, same distance, opposite side. Same distance, opposite side. Okay, so on this one here, let me fix my images here, or my graphs here, because they were kind of messed up in the process here of creating this document. So let me fix these first before I explain it so it looks good. There we go. One more here. There we go. Okay, so same distance, opposite side. So when you reflect across the x and y axes here, you know, I'm going to do the y-axis on this one here because I should have been more specific here. So across the y-axis means this way here. 2 units, A is 2 units away, so A prime is 2 units away on the other side, on the right side. B is 1, 2, 3, 4 units to the left, so 1, 2, 3, 4 units to the right. C is 1 unit left, so C prime is 1 unit right, and then you connect. Okay, and so my image looks like this. All right, I reflect. Okay, reflect. Same distance, opposite side. So this is across the y-axis. The y-axis right here. Across the x-axis, it'd be down here. So B double prime would be down here, and then A double prime would be way down here. And then when you connect across the x-axis here, it would look like this. and you would have another image down here. So when you reflect here, this is across the x, and the first one here in blue is across the y. So this one's across the y-axis, and this is the first one here, and the second one here is across the x-axis. This is across x-axis, and this is your what's called a pre-image. Okay, the original one's called a pre-image. All right, so on this one here, a prime would be 2 units to the left, right here. B prime would be here, 1 unit left. C is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is over here, C prime. So when you connect across when you reflect across the y, it should look like this here, right here. So here's your pre-image. All right, when you reflect across the y, you get image 1. When you reflect across the x, you get B double prime down here. A is 4 units above, so A prime is down here. And you get figure number 2. So this is across the x. And the x-axis here, and this one right here is across the y. All right, let me see. Let's do some translations, okay? Now, x plus 2 means right 2, and this means down 3, okay? So in words, right 2, down 3. So you go 1, 2, 1, 2, 3. There's A prime. 1, 2, 1, 2, 3. And there's C prime. 1, 2, 1, 2, 3. There's B prime. And then you connect. Okay, all it is, it's a slide or a translation. Come on. So the figure stays the same shape inside, it just gets translated. Okay, right 2 plus 2, down 3 minus 3. Now you try it, okay? Okay, so on this one here, this means left 3, up 4, okay? Left 3, up 4. So you move every vertex, 1, 2, 3, up 4. Oh boy. 1, 2, 3, 4. Right up here, A prime. 1, 2, 3, 1, 2, 3, 4. Up here, B prime. 1, 2, 3, 1, 2, 3, 4. C prime. And so your image is going to be way up here. Sorry for the overlap, guys. Okay, so it's going to get translated way up there. I should have made that y minus 4. Oh well, it's okay. All right, let's do some midpoint work. Midpoint formula, it deals with the average. All right, why? Because it's in the middle. So you want to take your x coordinates and add them together and divide by 2. You want to take the y coordinates, add them together, divide by 2. That's called your midpoint formula. All right, so you always have x in first, then y. So my midpoint for the first one here would be negative 3 plus 6. Okay, you look at the x coordinates first. Okay, and then you add them together, divide that by 2. And then you look at the y coordinates, and then you add them up. 4 plus negative 5, divide that by 2. 6 and plus negative 3 is 3, divided by 2 is 3 halves. This is negative 1, divided by 2 is negative 1 half. Okay? And that's all there is to it. You add them up, divide by 2. So on the next one here, you get to take negative 2 plus 4, divide by 2. 6 plus negative 8, divide that by 2. You get 2 halves, comma, negative 2 halves. That gives you 1 comma negative 1 for your midpoint. All right? This is your midpoint right here. And this is your midpoint on the second one. Okay, on these next few problems here, it says name the following angles. So this is angle recognition right here. Okay, these are alternate exterior. So angles 1 and angle 2 are called alternate exterior angles. All right, angle recognition. Right here, these are alternate interior. So remember, this is the interior. All right, that's what I did a long time ago. This is the exterior in blue. Okay, so interior, INT, exterior, EXT. So angles 1 and 2 are on opposite sides. We call that alternating. So angles 1 and 2, okay, 2 there, are alternate exterior now. Excuse me, I'm sorry, interior. They're in the yellow, right? Interior angles, all right? Or letter C, these are same side interior, same side. So angles 1 and 2 are same side interior angles, okay? Remember, they're supplementary when the lines are parallel, that is. Same side interior. And these are both in the upper left. Both angles are in the upper left positions, and that means they correspond to one another because they're in the same positions right there. And because of that, they are called corresponding angles. Corresponding angles. Okay? These are called vertical angles. So right here, these are vertical. When two intersecting lines, two lines intersect, they form vertical angles. Okay, they happen to be always congruent. All right, and these right here form a linear pair, and they are supplementary. So this is called a linear pair. Also, you have to know they're also called supplements, okay? They're supplementary. All right, last few basic facts here, and I think we're getting close to being done. I think. So name the 4 ways to prove triangle congruence. Well, the first one was side, side, side. The second one was side, angle, side. Then angle, side, angle. And then we had a theorem. It was called angle, angle, side. All right, that's for triangle congruence. All right. So all you have to do is look at the congruence marks to determine this. And here's the key. Okay, the key is look, okay, at the congruence marks. And if you do that and you go around the triangle, this is easy. All right, side, angle, side. So side, angle, side. These triangles are congruent by a side and then an angle and then a side. Let's go through the different cases. So here I've got one pair of congruent sides, and then the second pair here, and then the third pair here. Well, guess what? Side, side, side. So these triangles are congruent by side, 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 because all 3 sides of one are congruent to all 3 sides of another. And then we've got an angle, and then we've got an angle, and then we've got a side. So angle, angle, side here. And then we've got an angle, and then a side, and then an angle. So angle, side, angle here. It's that easy. Okay, and I think that completes the review. The only thing we need to do now is review constructions, and then we're good. So now what I want you guys to do is get all your construction notes out. So the last thing before we end this video here, and this is number 33, all right, get all your constructions out. All right, so organize, oops, gotta spell this right. All right, organize all your constructions and practice them. Keyword practice. That means redo, guys. And practice them. All right, make yourself proud. As I always tell my son, make yourself, all right, proud. All right, and work hard. And I'll see you in my next lesson. Mr. Ainsworth, signing off. I'll see you then.